if we want to actually understand perhaps the most important question of your own life, which is, what am I? Who am I? Why am I here? One answer might be I'm just a mass of particles in space-time, and I'm here because it's an accident. Well, that's the space-time story. And that story can't be right because space-time is not fundamental. So that means that we need to look for other stories. And now I'm not saying that means that spiritual traditions are right. It does not. It just means that we should take a look. From my point of view, consciousness is fundamental, and that space-time and the particles and objects that we see in space-time are merely a headset, like a virtual reality headset that some conscious agents, perhaps a tiny minority of conscious agents, uses in their interactions with other conscious agents. So space-time is nothing special from my point of view. It's merely a data structure.
I was thinking through some of these ideas that you talk about, and when we think about consciousness and physics going together and changing space-time to be more focused on consciousness, like, is this a extension of thinking about images on the cave wall?
I would say that it's very, very similar in spirit to what Plato was saying, that I imagine that if Plato had virtual reality metaphor available to him, he would have used that instead of his cave.
Mm-hmm.
So yeah, I think in some sense, as many philosophers have said, all of philosophy is a footnote to Plato.
Mm-hmm.
And what's new, I guess, is that science has advanced.
Mm-hmm.
And so we do have the tools of evolution by natural selection, the mathematics of that allow us to state Plato's idea with greater precision and greater scientific backing. Also, I think, for example, that Leibniz in his monadology was 300 years ahead of us in terms of his theory of conscious entities that aren't stuck inside space-time.
Mm-hmm.
So yeah, in some sense, there's nothing new under the sun. We're just able to take the old stuff and make it more precise and take it new places.
We always hear about the standard model, trying to understand where we are, to make sense of this world around us. How does what that is differ from what you're talking about?
So the standard model of particle physics is an incredible achievement, right? It has the bosons, leptons, and quarks that have been found so far to be, as far as we know, the fundamental particles in space-time. Although, we'll see. Maybe there'll be even more fundamental ones beneath them. And the standard model, first I want to say good things about it, right? It's an incredible achievement, and people should be justifiably proud of that achievement. But of course, any good scientist is going to be looking for, okay, what's next? And what are the weaknesses in the wonderful theory that we have so far? So there are several weaknesses that physicists themselves are acknowledging. For example, they cannot compute the masses of the particles from first principles. You have to measure them. So the theory doesn't predict the masses of the particles. It doesn't explain why there are 3 generations of particles. There are these generations that are quite interesting, and that's not explained. Surely there's something that needs to be done there. But I think most significantly to me is that it still assumes a framework in which space-time is fundamental. And physicists, especially high-energy theoretical particle physicists, such as Nimar Kani-Hamed and his collaborators and so forth, are saying that space-time is doomed. That's space and time. So not just space, but space and time are not fundamental. So that means that these particles of the standard model of physics, since they're particles inside space-time, and in many cases, physicists would say that what they are is simply what they call irreducible representation of the symmetries of spacetime, the Poincare group of symmetries of spacetime. So these particles are intimately tied to the foundation of spacetime. So when the high-energy theoretical particle physicists are saying that spacetime is doomed, that really is saying that we're looking for something deeper beyond the standard model of particles, because those particles are deeply wed to spacetime itself. And so it's in that sense that I would say that what many physicists now are doing is looking for new structures beyond spacetime, and therefore beyond the particles of the standard model, with the constraint, of course, that whatever new theory they have for structures, processes beyond spacetime must project into spacetime and give back the standard model of particle physics as a special case in that projection, or project to a generalization of the standard model of particle physics.
How does consciousness affect our understanding here, or us as individuals? How does it interact with a concept like this?
So if you're a physicalist and a particle physicist, you might say that consciousness is neither here nor there. We don't need it, they would say, in our theory of particle physics, and so it has nothing to do with it. That's one framework, and I would say that a large group of serious scientists take that point of view. They do have the problem that they will acknowledge that in quantum theory, you have the Schrodinger revolution of particles and their states, of systems and their states, when things are not being observed. Then you have the Born rule, which tells you how to predict the probabilities of various measurement outcomes. And then you have the measurement postulate, a third thing, the measurement postulate that says that an observing apparatus or an observer will, in some way that's not really specified, collapse the wave function to a single state that has 100% probability. And that measurement postulate cannot be done by the Schrodinger equation. It's not a linear evolution. So the physicalists then have the issue that when they are talking about quantum theory and measurement and observation, the observer or the apparatus is taken as an extra postulate. It's not reducible to the particles. Right? So reductionism fails. So that's the real issue. And so that's why you get all sorts of extreme many worlds interpretations and so forth of what's going on there. Because if you want to avoid consciousness, then you need to have some other answer for why you switch from evolution, the Schrodinger evolution, to another evolution, which is not when you talk about measurement. Your question was, so what is consciousness and how does it affect things and how does it relate to this standard model of particle physics? My attitude on that is that the standard model of particle physics really is a representation of a particular data structure, a space-time headset, and consciousness is the fundamental thing. So reductionism is indeed false. I mean, what I've talked about earlier, that you can't get the measurement postulate from the Schrodinger equation. They're not compatible.
Right.
So I say, yeah, the observer is a primitive. In fact, consciousness is a primitive, and it's different from the Schrodinger evolution, but we now take that as a primitive of our theory. So in my point of view, consciousness is fundamental, and many spiritual traditions have been saying that consciousness is fundamental for thousands of years, but that's not science, that's spiritual traditions. To make this a science, we have to take that statement and turn it into a mathematically precise dynamical system and say, this is precisely our proposal for what we mean by consciousness, and this is our precise mathematical proposal of the dynamics of consciousness, and this is our precise mapping into space-time to give us exactly, for example, the momentum distributions of quarks and gluons on the interior of a proton. When we can do that, then we'll have something for people in the sciences to take serious about the notion that consciousness might be fundamental. Until then, of course, it's just a promissory note, and I have every respect for a scientist who would say, when you have the beef, come back and tell me, but not until then.
Wait, stop. You're all ahead of me and way over my head, but
Okay.
No, it's wonderful. It's okay. It's good to stretch. But consciousness is fundamental. I mean, when was that idea of consciousness come into being? Like, who said, okay, that's it? And are human beings the only ones that have consciousness? Like, who discovered consciousness? Who said this is it? I just want to go back for a minute.
Well, of course, now that's been, in some sense, a central idea in many mystical spiritual traditions, in Buddhism, Hinduism, and mystical Christianity, mystical Islam, and so forth. So that idea is not new. That's gone back for thousands of years. Trying to say it precisely, trying to turn it into a mathematically precise theory is relatively new. Now, Leibniz, in his monadology, put out something that I would argue was very, very similar to what I'm saying. He had these monads, but they're perceiving entities. I would say that, yeah, he's saying that there are conscious entities and they're fundamental. Now, he didn't write down a mathematical model of it, although I think that with his mathematical genius, he could have. But I haven't seen him do a mathematically precise model of it. So what we're doing right now is, in some sense, we're taking Leibniz's idea and we're putting mathematics to it. And maybe there's a slight twist on it that would have been different from what Leibniz would have wanted, in which case we're probably wrong and Leibniz was probably right. But anyway, that's what we're up to now. So there's a long history to this, but the history of trying to make the notion that consciousness is fundamental and gives rise to space-time and physics, that has only very recently been taken as the starting point for a scientific theory in which we have precise mathematics. So that's new.
Is it sort of the same way of thinking about it? Like, at first we thought that everything revolved around the Earth, then we realized we revolved around the sun, and then later we realized we're just a small speck. And each time we have to reframe our understanding of the standard model to reflect these new insights. And consciousness might be the next insight.
I would say that that's right. in the sense that, yes, we had to go from flat Earth to almost spherical Earth. And then from the notion that the Earth is the center of the universe to no, it's not that particularly special, perhaps. Although there's been some interesting stuff in the cosmic microwave background radiation that is now making scientists scratch their heads about that. But anyway, but now the big one is we've assumed that space and time are the final stage on which the play of reality takes place. And that seems hard to question, right? What could you mean by something beyond space-time? I mean, if you keep going in space, you're never going to get to the end. So what do you mean beyond space? How could, and so it's hard, but the physicists themselves, as I mentioned, the high energy theoretical particle physicists like Nima Kani-Hamed and others, David Gross, and Nathan Seiberg, and a bunch of them now, are saying that space-time is doomed, and they're looking for new structures entirely outside of space-time, not curled up in tiny dimensions hidden inside space-time. These are objects in dimensions utterly outside of space-time, and space-time itself is in some sense a trivial projection of this much more complex realm.
So is it a projection in the same way my computer has all these little images all over it, and those are not really the inside of the computer, but when I hit them, they activate things deep inside the computer?
That's right. So the screen on your laptop, for example, or of your phone, is a nice interface to an incredibly complicated machine. Tons and tons of diodes and resistors and voltages, magnetic fields and software. It's really, incredible what's packed behind your phone. If you had to toggle voltages inside your laptop to craft an email, you'd never get it done. Knowing the truth is just too complicated. And so in that sense, space-time is like the simplified, dumbed down desktop or the screen of your phone. So we thought that it was the final complicated reality, and it is complicated, but compared to the reality beyond it, space-time is trivial. So for example, neuroscience, which is where many of my colleagues are studying consciousness, neuroscience is incredibly complicated. There are, 86 billion neurons roughly in the human brain and trillions of synapses, unbelievably complicated. But that's just the interface representation of a much more complicated reality. We need more money for neuroscience because it's much more complicated than we thought. We have to reverse engineer the brain to find out the really complicated structure beyond space-time that projects to what we call the central nervous system and its neurons and synapses.
So is it each one of us individually has a certain consciousness, or is there one consciousness that oversees it all? Are you thinking there's another being? Are we inside a projection in some sense?
So spiritual traditions, of course, have said something on this for millennia. And many of them will say that in some sense there's just one, and we're all projections or images or children of the one, depending on which tradition you come from. In the mathematical model that my team and I have been working on, we didn't think that we could write down a mathematical model of the one ultimate consciousness. So we didn't even try to start there. We said, let's just try to write down a mathematical model of small finite consciousnesses. And when we looked at that, then we realized that the mathematics told us that given our mathematical definition, whenever we had conscious entities, conscious agents interacting, the group of them that were interacting also satisfied the definition of a conscious agent. And therefore, it was a single conscious agent. So that then took us on the path of recognizing, oh, wow, okay, take as many conscious agents of the finite kind or small kind as you want, take like a countable infinity, agent 1, 2, agent 3, 4, 5, up to infinity, take those. Any collection of them that's interacting is a conscious agent. And it turns out that all the possible collections is a bigger infinity. So it's a bigger infinity than the countable infinities, like 1, 2, 3, 4, up to infinity. That's the smallest infinity. There are infinitely many different infinities. Each one in the succession is called Cantor's hierarchy. Each level in Cantor's hierarchy, the infinity gets bigger. So what happens is when we take a bunch of agents at the smallest level of infinity, we get agents at a higher level of infinity and a bigger collection of a bigger infinity. When we take all their subsets, we get yet another bigger infinity. So what this means is that our math is telling us, so we agree with the spiritual traditions that say there is ultimately one conscious agent. We can say that it's there. We can climb Cantor's hierarchy toward it, but we can never get there. So that also is something that the mystical traditions would have said for a long time, that the one consciousness could never fully be explained by science, but at least it can be predicted.
When we talk about Newton and, an apple bumps him in the head and falls on the ground, you can see what he's modeling. Where does the math begin on how to model something? How do you make consciousness into algebra?
Well, if you look at what, for example, Newton and others did with space, and suppose I ask you, okay, look around space, what mathematics are you going to use to talk about it? How do you put numbers to points in space? You might imagine scratching your head and going, well, holy cow, how do you do that? That was not a trivial accomplishment for them to figure out how to put numbers on space. Mm-hmm. And so what we have to do when we start to put numbers on consciousness is, in that sense, no more weird or complicated or hard than what Newton and the early physicists had to do when they started making numerical predictions about space and time and so forth.
A lot of these traditions that you're talking about of Judaism, the original ideas, or any of these religions or just any kind of belief systems, I guess on a certain level, that's also the same as sort of a Silicon Valley ideology where we think that, we're living inside a simulation. Do your own thoughts go to that? Do you think we're living in a simulation? Does that dovetail with some of these earlier beliefs?
So the simulation idea is similar, but there's a huge and important fundamental difference between that idea and what I'm describing. Nick Bostrom is one of the names associated with this kind of idea. Mm-hmm. And in that particular version of the simulation hypothesis, the idea is that, you and I, we think we're real, but in fact, we're just simulations that some geek on their laptop in a different universe has programmed up. And we don't know that we are confined to her laptop that she's geeking out on. And why stop there? That geeky programmer that created us is herself just an artifact or a simulation in yet another level down laptop. And so who knows how far down this goes? But in Bostrom's view, this is all done in a situation in which the bottom level, whatever it is assumed to be a space-time level. So space-time is still taken to be fundamental. So our space-time as we perceive it may not be the true space-time, it's just a virtual space-time, but the fundamental reality is still taken to be a space-time reality. For the base programmer that started the whole series of simulations. So that is fundamentally, I disagree completely on that. And that's a critical point, right? Because I'm saying that space-time is not fundamental. And that means the very basis for his entire hierarchy of simulations gets wiped out, on my point of view. There is no fundamental space-time. But there's another problem with the simulation theory. And that is that they're assuming that a computational system can actually create our conscious experiences, or if you don't believe in conscious experiences, are illusions of conscious experiences. And there is no scientific theory at all that explains how any specific conscious experience, like the taste of chocolate, smell of garlic, feeling of a headache, no specific conscious experience can be derived or explained by any current scientific theories, and not even close. And by the way, the theories like Bennett and Keith Frankish, Keith is a good friend, brilliant guy, but we have to talk turkey when we're talking about where we disagree. So Keith and the others who say that consciousness is an illusion, that's perfectly fine to take that as a philosophical or scientific point of view. But as a scientist, then I ask you specifically, what computational system or whatever you want to propose as the foundation, what computational system and what program must be the illusion of the taste of chocolate and could not be the illusion of the taste of vanilla? In other words, to say that conscious experiences are illusions does not get you off the hook. You have to give me a scientific theory about what specific computational processes must be the illusion of chocolate and could not be the illusion of, garlic or something like that. So the Bostrom approach to this idea of the simulation theory assumes that computational systems can boot up specific conscious experiences, and there's not a shred of scientific theory or evidence that supports that idea. So there are two problems with it, and two ways to summarize how my view of consciousness being fundamental differs from the simulation theory. Simulation theory assumes that the foundation for the first simulation is space-time, and there I disagree. And second, it claims that conscious experiences or the illusion of specific conscious experiences can be created by computational processes. And there is no scientific theory that remotely makes that second claim plausible. Nothing is on the table. So that's where I differ. So my claim is that when I say that this space-time is like a VR headset, what I'm suggesting is that there's this, much like the monads of Leibniz. So the monads are not stuck in space and time. These are fundamental perceiving entities. So take conscious agents as entities not inside space-time, but just a social network, just a vast social network beyond space-time. But what do you do when you have, big social networks like Twitter, the Twitterverse, or X as they now call it? Well, there are millions of users and billions of tweets. There's no way for you to grok the whole Twitterverse. I mean, it's just way too complicated. What you have to do is, and this is how we deal with all sorts of social networking data, you need to have kind of visualization tools to help you say what's trending here, what's happening over there in Australia that's different from what's trending in California, for example. So you have different visualization tools. And that's what space-time is. And from my point of view, there's this huge social network of conscious agents. And some of them use a trivial space-time headset as their way of navigating things. And I think that space-time is probably one of the more trivial headsets. It's only 4 dimensions, 3 of space and 1 of time. I think we're dealing with one of the cheaper models. I would be much more happy to have, why not 50 billion dimensions of space and time? Why not 50 trillion different colors? We're stuck with 3 different cone systems and whatever colors we.
Our primary colors, right? That's what we got.
Right.
Yeah, we got the cheap version of the of space-time.
That's right.
Yeah, it's a good way to think of space-time. Also, the Twitter example is great because it's what's floating around. Some of it you don't want to see. It's space trash, maybe. My question is there a place for artificial intelligence to come into this conversation to help scientifically to dispute or to verify consciousness? Is there consciousness within, or are you interested in that question, or is that irrelevant?
Actually, I started off my graduate career in the artificial intelligence laboratory at MIT, precisely because I was interested in the very question you're asking. So I was in what's now the brain and cognitive science department because I wanted to understand the cognitive neuroscience of consciousness, but also in artificial intelligence because it certainly seemed an open question whether consciousness could be created by machines like AIs. And so I wanted to see what can an AI do? And could it actually create consciousness? And what is the neuroscience of consciousness? And so my take on it is absolutely, that's an incredibly important question. I started in the AI lab at MIT in 1979, so I've been after that question for a long time. My advisor, David Marr, was a professor in the lab, and I got to take a class with Marvin Minsky, the founder of artificial intelligence and so forth. So I'm really into it. And my take on it after I've studied what AIs can do is what I actually mentioned a few minutes ago, that there is no evidence right now that any computational system, including an artificial intelligence computational system, can give us a theory of specific conscious experiences. There's just no theory on the table. Now, you'll see lots of theories of consciousness out there: integrated information theory, global workspace theory, orchestrated collapse of quantum states of microtubules and neuromolecular tubules. There's attention schema theory, another one. So there's a number of physicalist theories that could, in principle, have a computational implementation or a quantum computational implementation in the case of orchestrated collapse of microtubules. And the people who are proposing these theories are, of course, they're brilliant and they're well motivated, and some of them are friends of mine, but there's nothing on the table that will explain even one specific conscious experience. Nothing that would say that, this is the orchestrated collapse that must be the taste of chocolate, or the neural pattern for an attention schema that must be the taste of garlic. There's just nothing on the table. And I think that's for principled reasons. It's not because these people are dumb. They're brilliant. If it could be done, I think they would have done it. It just can't be done. So when the physicists are telling us that space-time is doomed, what they're telling us is that trying to boot up consciousness from anything inside space-time is doomed. I'll say that again, because that's really important.
That is
saying that space-time is doomed means that trying to boot up consciousness from anything inside space-time, particles, neurons, whatever, attention schema, integrated information, all of those are doomed because space-time itself is doomed.
It's like with neutrinos, we don't know why they change, and we're building giant experiments to try and help us look into this, where we're beaming things through the earth to try and understand this sort of fundamental building block of the universe.
Right.
Is this a case where you can come up with an experiment like the recent gravitation experiments or the new telescopes? Is there a way to test this with experiments?
Right. So the experiment you mentioned is about neutrino oscillations. Really quite interesting. And there's work going on at Fermilab here in the US and with collaboration with CERN and so forth, sending them hundreds or thousands of miles through the Earth. And I'm all for it. I mean, that's really good stuff. And we need to do that. So when I say that space-time is doomed and particle physics is not fundamental, that doesn't mean we shouldn't be doing, we need to do more research on it because we really need to understand our headset. If we want to reverse engineer the headset, you have to really understand the headset. So all that data is absolutely essential. So hats off to the brilliant scientists who are doing these experiments. Now, you asked, could we test this theory that I'm talking about in consciousness is fundamental? There's a mathematical model of, could we test it with the same kind of rigor that we're trying to test neutrino oscillations and so forth? And I think the answer has to be yes. If it's not yes, then this isn't science. What I'm proposing is no longer science. So to put it this way, if I eventually cannot predict the exact distribution of the momenta of quarks and gluons inside the proton at all values of what they call Bjorken X and Q squared, the spatial and temporal resolution of which the colliders are examining, if I cannot, from a theory of consciousness, get exactly the momentum distributions of all the quarks and gluons at all Bjorken X and Q squared, then I'm wrong. So the answer to your question is, if we cannot do what you asked, then no one should take us seriously. But if we can do it, it doesn't mean we're right. It just means that this is now the next baby step that maybe we should take seriously as we move outside of space-time.
Can you clarify for the audience, though, when you say space-time is doomed, what does that actually mean? Like, how does that translate into, let's say, somebody's everyday life? Does that have an implication?
The reason why they say space-time is doomed is that it turns out when you get down to small scales, like 10 to the minus 33 centimeters, space-time ceases to have any operational meaning. There's nothing you can do with it. When you try to talk about 10 to the minus 35 centimeters, there's no experiment that you could use to test what you were talking about. So there is no operational meaning. Also 10 to the minus 43 seconds. So that's called the Planck scale. And the mathematics of space-time is very, very clear. It basically ceases to have any operational meaning at the Planck scale. And this is an argument that was given by David Gross, who won the Nobel Prize for his work on quantum chromodynamics. So he has a 2005 paper in which he basically says space-time is doomed because it has no operational meaning beyond the Planck scale. So that's why we say space-time is doomed. But now what does this mean for us personally and our consciousness? I mean, or is this just some abstract scientific thing that has no personal meaning? My take on it is that it has an incredibly important personal meaning. Most of us deeply believe psychologically that we are just little objects in space-time. I have this little body that weighs between 100, 200, maybe 300 pounds. And that's me. So most of us, our self-image that no one teaches us is just sort of what we're born to believe. We just naturally believe that I am this little body in space-time. So to say that space-time is doomed, and therefore the objects inside space-time are not fundamental, they're not the fundamental reality, means that the very conception that I have of myself as a human being, that I would say 99.99% of all people have, even without tutoring, without training, I am this body. When this body dies, I'm kaput. That's false. The entire framework of that is just plain false. And science says that that framework is false. So if we want to actually understand perhaps the most important question of your own life, which is, what am I? Who am I? That is, in some sense, the biggest question to ask and try to answer for yourself in your life. Who am I and why am I here? One answer might be is, I'm just a mass of particles in space-time and I'm here because it's an accident. Well, that's the space-time story. And that story can't be right because space-time is not fundamental. So that means that we need to look for other stories. And when we start to do that, now I'm not saying that means that spiritual traditions are right. It does not. It just means that we should take a look.
Yeah.
Point.
I mean, I love where you said, because that does lead you to ask a different question. So if you're saying, once I die, I think maybe that's it, but maybe not. Is that the link between spirituality and physics? Or is there a link there to continue to put, to Jesse said, some rigor in understanding that question or looking at that convergence or that moment where I cease to exist?
That's my hope. For example, the work that I'm doing on what I call the theory of conscious agents, that mathematics itself, of course, will not be the final word, even if it works. It will just be the next baby step. But I'm looking and I'm talking with various spiritual leaders of various traditions or followers of various spiritual traditions, not because I think that they're absolutely right, but because I think that they have some good ideas. And it's important to listen to those ideas. Just like in science, I think there'll be good ideas and there'll be things that people will deeply believe in spiritual traditions that will turn out to be deeply wrong. But burying your head in the sand or not listening to those traditions is definitely not the thing to do. So I'm very much listening, and I'm hoping that eventually there will be this convergence between science and spirituality in which both bring something important to the table. The spiritual traditions bring thousands of years of exploration, meditation and so forth, of the possibility of human consciousness beyond spacetime. And what science brings to the table is a rigor of experiment and theory that has been lacking prior to the Renaissance, that we just didn't have that kind of rigor. The scientific revolution really brought that rigor. And so we can take then the ideas that spiritual traditions have had for thousands of years, start to make them precise, find out which ones survive, which ones get tossed, and then find out the limits of those concepts, because the mathematics will always, see, when you have a mathematical theory in science, the mathematics tells you the scope and the limits of the assumptions of your theory. That's what the mathematics does for you. But it is not just the scope. It doesn't just tell you the scope. It tells you the limits of your theory. And that last part is really, really critical, because that is the death of dogmatism. And that's what we have to have, is the death of dogmatism. Dogmatism is the sure way to stop further inquiry and to stop growth, to stop exploration. So scientific theories, if the math is done well, it will tell you the potential of your assumptions. It will also tell you where those assumptions fall on their face and where you need a new, richer framework. So one problem that spiritual traditions have had is that their ideas have been couched in words alone, not mathematics, and words are imprecise, and they are so prone to get believers who are dogmatic about the words. And that then stops all progress, including the very important progress of understanding who we are as human beings. See, my attitude is that there's no end to the exploration. In principle, no end. So the only attitude to have to any statement, whether it's a spiritual tradition saying something in words or scientific theory saying something in mathematics, is this is at best a next baby step in our exploration. It can never be the final word. And so you can see that dogmatism just is a non-starter.
Well, it shuts you down. It shuts you down. I'm suddenly very hopeful. It started out as a challenging conversation. I'm feeling very optimistic, though, about this endless possibility of questioning, right?
Yeah.
Absolutely, in principle. And I think that endless possibility says something about the other question we brought up, which was, who am I? I am, and you are, infinitely complicated. There's infinite to explore there. And that's what perhaps this is all about, is what we are is the one conscious intelligence exploring itself through a particular headset and saying, okay, this is what I look like, pretty trivial headset, but this is how I see myself. And ultimately, what you realize from this point of view is that the other person that I see, well, that's really me, just with a different headset on.
Yeah.
And so is my cat. And so is that tree.
Yeah.
And so is that microbe. And so is that virus. And so is that atom of silicon, and so forth.
Yeah, it's a lot to think about.
So much. I have one last question before we let you go. Because I remember the moment like where I was aware of consciousness, like I was aware of something about my own being, and very little. I mean, very, very little. And it was overwhelming and anxiety provoking, but then it was really exciting. What was that moment for you where you wanted to be studying these? Like, how did you start to think about all this? Why did you want to think about these things?
For me personally, my own little story about it was, my dad was a minister in a church, a Christian fundamentalist church. And it was, the Bible is the absolute word of God. Every verse is absolutely true. And those who don't believe precisely as we do are going to end up in hell. So I was raised in that kind of thing. But then, when I studied science in school, I was getting a completely different kind of point of view. And so I decided that I needed to explore for myself. And so that's why I was interested in studying computer science, artificial intelligence, human psychology, cognitive neuroscience, to have at least those pieces of the puzzle to try to put it together for myself. So, and that's why I went to MIT and those two different, the AI lab and the brain and cognitive science department. So that was sort of my story, but I didn't really come to the point of view that consciousness must be fundamental until after I became a professor at UC Irvine. I've been a professor for 3 or 4 years and was working with Bruce Bennett and Chetan Prakash on this mathematical model of what we now call conscious agents. It was the mathematics of that made me all of a sudden sit down and realize that, wow, space and time may not be fundamental. It may be true that consciousness is fundamental. I still remember the moment in my lab when discussing with Bruce Bennett and my collaborator about the meaning of the mathematics that we were writing down. When I really understood what that mathematics was saying, I had to sit down because it was a real shock to the system. I think we're all born physicalists. We believe that space-time is fundamental deep in our bones. We're very, very afraid of death as a result and so forth. So to have some kind of science actually strongly suggest otherwise was such a shock to my system that I will never forget the moment.
Great.
Incredible. Thank you so much.
Yeah,
This is
thank
wonderful, challenging, invigorating conversation. Thank you so much.
My pleasure.
Yeah,
Thanks for inviting
thank
me.
you.